Hi, I'm Johan PB. I'll be talking about the inner workings of Safepoints. Essentially, what are Safepoints? You essentially have this nice little VM and you stop it. And as you saw, like we have local Safepoints that only stop one VM, the other one just float across in the vicinity, and the other thread just worked. So they're local Safepoints. They are quite cool because we stop a thread, a single thread, the thread doesn't modify its stack anymore. And it's nice to do things like garbage collection that just wants to operate on the thread stack. And we also have global Safepoints. They are also quite interesting. So essentially, you stop all the threads. That's cool when you want to do like code deoptimizations and other stuff. And that's what we're talking about, Safepoints. At Safepoints, you have either the state of the whole VM is guaranteed to be stable, or the state of a whole thread is guaranteed to be stable. And they are like one of the building blocks of the JVM. And they get even more important. I'll link the chat below because newer garbage collectors like Concurrent, ZGC use Safepoints, especially the thread local Safepoints, to do work concurrently and to ensure that we can do as much work between alongside concurrently every now and then at returns of methods instead of having a stopped of all garbage collector as we have before. So essentially, when do we ask to be in a Safepoint? So when do we check, hey, should we go into a Safepoint? We take here a typical method, it just multiplies. And so what we see here, we go into a Safepoint either when we return from a function, which is pretty neat, or when we're at the back edge of a non-counted loop. So here in this example, we check at the Safepoint every time here when we're here, or when we're at the end of the function. But beware of inlining, and that's the problem here. When we inline a function, then we don't have a Safepoint at the end of this inline function because the function doesn't exist anymore for the JVM. And then, of course, we sometimes have loops. Some of you have written such for loops, and the problem is some years before, this didn't have a Safepoint anyway inside, and especially if B got really large, it meant that the JVM was taking quite a long time to reach the next Safepoint, so people started to do loop strip mining, and the idea is essentially you split this loop that we had before into an outer loop that usually iterates like over increments like the value by 1,000 typically, and an inner loop, and we have a Safepoint here. And that's quite interesting, that's quite good. It's called loop strip mining, and this reduces the latency in your JVM quite nicely. I'm Johan PB. I usually talk about profilers and sometimes about Safepoints. I work with an amazing team of talented engineers at the submachine team. We're the third biggest contributor to this little OpenJDK project that you might have heard about. And I sometimes fix bugs in template interpreters. So template interpreters, like the thing when people say, oh, Java code is interpreted in the lowest level of JIT compilation. Then they talk about template interpreter because the template interpreter turned out to not produce Safepoint checks at the return of functions. And that's not great when you use this fact. So I sometimes fix bugs in the OpenJDK, and sometimes people call this work. And they backported these fixes to all older LTS releases. What I'm not talking about is, I'm not talking about how Safepoints suck, because they sometimes suck, especially when you have profiles that are Safepoint biased, so that only sample your thread at Safepoint borders. As Nitzan Wacker says, Safepoint biased profiles are tricksy, sneaky, filthy, all of the above. And if you want to know more about Safepoints and why they suck in profiling, ask this guy in the front. He knows a little bit about it. But more on the real topic of my talk, it's on the implementation, because we're all here to see some C code. Yay! In the beginning, I want to tell you how how they could work. So essentially what we want to know, so essentially how Safepoints works, we have to insert these checks somewhere, and then the JVM goes into a SafePoint handler and does all the amazing stuff like doing garbage collection work, or hopefully in the future doing some SafePoint-based stack walking to make profiling a little bit easier and to make profiling a little bit faster. But essentially what we could do in the source code, we could ask at every return, at every point where we want to insert a SafePoint poll gesture, if red is at SafePoint, please call SafePoint process. And the thing is, this is like this would compile in the OpenJDK if you include some headers, and then in the last branch we do nothing. And that's quite cool, and it's slow, of course, because we have this branch everywhere. But the cool thing is, for once, like, that's pretty rare, this occasion. And so we can do some tricks. But what's in interpreted mode, how it looks like, and here a bit of C++ code, how it actually looks like, that your template interpreter generates some code that calls a test instruction that essentially sets a conditional bit, and it just tests that the polling word, that the poll bit is not 0. So that's just a simple checks. That's how it's implemented in template interpreter. And so we could essentially just implement this, and it's implemented this way. But we see that like the first thing is used pretty rarely, because usually we're not going to be at a safe point, because if we would like get into this at every return, at every loopback edge, we would be just like being at safe points, and we want to do some work with our JVM. So usually at safe point fails, and this is cool because we now know that we can essentially make this a slow path, so it doesn't matter that much how fast it is if we get a fast path really fast. And one idea here is we could just read from a pointer, because reading from a pointer in the fast path is like quite fast, especially if there's a pointer that's in the cache or somewhere. It's nice. And the thing is, when we read from a pointer, there are two options. We could either read some data, good, like it's just a simple morph instruction, or we can get a segmentation fault. And that's one of the things that JVM does. It uses segmentation fault for its own advantage, because segmentation faults, yeah, they are somewhat expensive, but the fast path is really, really fast. So the idea is here in our method where we insert a check, we just access a so-called polling page, because when we disable the safe point, when we're not pointing, the fast path is, yeah, it points to a good page, this pointer. But when we enable it, it points to the bad page, and we have a segmentation fault, and then essentially what segmentation fault handler does, it looks, hey, did we want to access a safe point, such a safe point page? And I'm like, cool, we're probably at a safe point. And that's one of the reasons why when you disable safe points, or when you do safe point handling stuff around your JVM and want to be sneakily, so capturing safe points, you got a lot of them. And that doesn't help with debugging when you open it in GDB, because you get a lot of safe points. But anyways, so before we go further to looking into C++ code, I was told by someone in the audience that people like cute cat images. And the thing is, working with the OpenJDK is interesting, but it's sometimes you have to calm down, take a cat, stroke it, have a nice time, and then you go back to learning how the OpenJDK works. So I learned this because I wanted to fix a bug. So essentially how safe points are initialized, we have here a bad page and a good page, and then we use the magic method protect memory. Essentially what it does, we call mprotect, and this thereby we make the bad page neither readable nor writable, and the good page we make it just readable. So we don't need to make it writable. So essentially we use the memory management unit of our CPU to implement safe points, and that's pretty nice. So how, for example, C1 implements SafePoint polls is quite simple with this. It just accesses the pointer, like it just accesses the value that's at this address. That's our page. So it's really just a single address, and that's a single moth, which is nice. And there's, of course, the question, how could we arm these? So what do we do here? And essentially what we do, we, for one, set the polling page here when you arm it to like the arm value, like the bad page. And of course, we're not doing any of the segmentation fault track in template interpreters. So we're also setting the polling word so that the template interpreter can also check it. And what we do when we do a global SafePoint poll, we essentially do this for every thread. That's pretty simple here. And of course, sometimes you want to track SafePoints because they can get quite annoying. And if some of you saw this 1 billion row challenge, then you probably saw that some of the winning contenders did disable SafePoints because they can get quite annoying. But usually they aren't. So essentially, there are a few ways. You can, for one, use JFI events. And I've built a website called JFI Events Collection where you can see all JFI events available, also the events for Crowl and for all the JDKs here. And you see here that there's a SafePoint begin event, and you also have a SafePoint end event, so you can check which SafePoints are created. And also you can just pass xlog SafePoint. You get lots of output. And I did this for like a randomness benchmark, and this is like the distribution that I get. And essentially most of the SafePoints are in this case related to G1, because G1 was my selected garbage collector. And if you want to learn more about me or my team, just go to this link. I was Johannes Bechberger here, telling you a bit about the inner workings of SafePoints. I hope you learn a bit. You can find me on Twitter, on GitHub, or my team at submachine.io. That was all from me. Yes, of course, we have 4 precious minutes. Any questions here from the JDK nerds? Or any corrections of the OpenJDK developers?
I have a question, but it's not directly related to SafePoints. As far as you know, before Java 5, no SafePoints were used, but code was rewritten. Do you know anything how that worked?
Can I ask the Joker? So the question was before Java 5, how did it work? Any of my colleagues that were present at this time in the JDK? Any of the OpenJDK developers here? Any ideas? I don't. I only started 2 years ago. No problem. If these people don't know, then nobody knows. But if you have some ideas, come to FOSDEM next year and tell people about it. Yes, history lens. No, other questions? None? Good. Then it was a pleasure talking to you. And if you want to learn a bit more about Python, I'm tomorrow at 4 p.m. in the Python dev room telling you about Python monitoring. And that's all from me. Thank you.